Hello everyone, so today we are going to study about the measures of dispersion. So those of you who haven't watched our earlier video on measures of central tendency, then I'm linking that to the I button. So just click on that and watch that video first. Because if you won't watch that, you may not be able to decipher everything that I'll be teaching in this video. Okay, so that is something that you have to do. Now let me tell you something about myself. So I'm Yogesh and I'm a UGC-NET-JRF qualified candidate, and as of now I'm pursuing my PhD. So now let us continue with our topic, that is dispersion. Okay, what actually is dispersion? So when we are given a set of values means we are given a distribution. Okay, so how close the values are to each other? Okay, so that is variability. If those are very close, that means the variability or the spread is quite less. If those values are very much spreaded, okay, so that means that those are actually highly dispersed, okay, or having high variability. So I'm just telling you some examples over here, so that those examples will be helping you in understanding the concept in a better way. Okay, so now suppose the values that we are given are 2, 3, 4 and 5. Okay, so here you can see the values are basically lying between 2 and 5, and at another level, so 2, 4, 6 and 8. So here you can see that the values are more spreaded. Okay, they exist between 2 to 8. So here the range is something 5 minus 2, and here the range is 8 minus 2. So it comes out to be 3, it comes out to be 6. Okay, so we can say in a way that the observation number 2, okay, it is more spreaded. That means it is showing more dispersion. Okay, so what will happen then? So if something is showing more dispersion, that means the values are less consistent, okay, less predictable. Okay, that's why. And why do we need to use this concept of dispersion? Okay, so we will be understanding that in the upcoming slides. So before going to that, let me tell you something about different methods of studying dispersion. So one was something which we studied previously, means in the previous slide only. So that was a range. Another is semi-interquartile range, or we can say quartile deviation. So quartile deviation is nothing but semi-interquartile range. Okay, then mean deviation is something that we have to study, then standard deviation, and then variance. So these two are very important concepts for us, and along with these we have to study another topic also, that is standard error. Okay, so these are very important, and once we will be able to understand them quite well, then definitely we can move to the moments like kurtosis and skewness, and along with that we can study the test of significance. So those will be taught to you in our upcoming two videos. Okay, so let us first study about the importance, like why we need this kind of measures. Okay, so suppose you have to paint your house and you are like quite confused which brand to go with. So somehow you try to narrow down your choice to just two paints. Okay, so say you are left with Asian Paints and Berger. Now you are confused which one to go with. So you just thought in your mind that I should check the average duration for which they can stay on the walls, and you got some data, but the data came out to be showing the similar value of averages, means the duration for which they can stay. Then you again got confused and you were not knowing what to do. Then you met some statistician and he told you that you can look at the spread, and once you will be looking at the spread, you will be able to make decision quite well, because spread will help you in understanding the consistency of that paint. Okay, and let us look at that with the help of example. Okay, so this was paint A, say Asian Paints. Okay, so this was Berger. Okay, so what you did is you took data from somewhere. So this was for location 1, 2, 3, 4, 5. Okay, so these were the six location. Okay, so paint A at location 1 stayed for 10 months, paint B stayed for 35, paint A at another location stayed for 60 months, it stayed for 45, then 50, 30, 30, 35, and so on. So what we will be doing, we will be doing summation. Okay, because we are going to find out the average. So for average, we will first do the summation of both the data. Okay, so here it comes out to be 200, here also it comes out to be 200, and observations are same for both of them. That means divided by 6, and it comes out to be something around 35 months. Okay, and it is also 35 months. So here you can say that the average duration for which both the paints can stay on the wall of the houses is exactly same, 35 months and 35 months. So you are confused like which one to go with. So how will you be able to solve that problem? And that is shown in our next slide. Okay, because average is not helping here at all. Okay, so we will consider spread. So when we will be looking at this, okay, so we can see that the lowest value in this whole data set is 10 and the highest value is 60. That means our range comes out to be 60 minus 10, that is 50. Means the spread is quite high. However, when we'll be looking at the paint B, then the lowest value is 25 and the highest value is 45. So the range will come out to be 45 minus 25, that is 20. So here the spread is quite low, that is 20, and here the spread is 2.5 times. Okay, means it is 50. Okay, so then you can understand that it is performing in a consistent way, more consistent. Okay, so which paint to go with? The one that is more consistent. Okay, and definitely we can understand that since this is having lesser spread, so it is having lesser variance, and we can go with it. Now let us move to our all 5 measures of central tendency one by one, and we will be understanding those. So range is the one that we studied just now. Okay, so range is basically the difference between the highest value and the lowest value. So that is range. Okay, so we need not to go into depth of that. And coefficient of range is basically a ratio of the difference as well as the sum. Means largest value minus smallest value upon largest value plus smallest value. So it is basically a ratio of the difference as well as the sum. Okay, now you can look at the example and you can solve them on your own. So those are quite simple. Now interquartile range. Okay, interquartile range, we can write it by IQR. So IQR, so before understanding IQR, you should first know what is quartile. And those of you who don't have any mathematics background, okay, so you guys must not be knowing about quartile, but you must have heard something called percentile. Okay, percentile. Okay, so what is percentile? Percentile is, for example, if someone says you like, I got 99 percentile in CAT. Okay, CAT is an exam that is conducted for doing MBA. Okay, so if he scored 99 percentile in CAT, then it means that he scored better than okay 99% of the students. Okay, he performed better than 99% of the students. So that is the meaning of percentile. Okay, okay, and if he has scored 75 percentile, that means he has scored better than 75% of the students. So it is quite easy. So in the similar fashion, means percentile comes from percent. Okay, decile is there. Decile means 10. Okay, out of 10. Okay, then we came to something called quartile. Okay, quartile basically relates to quarter. Quarter is 1/4 of something. So if we are talking about 100, okay, so how many quarters can be there? Definitely 4 quarters can be there. So the first 25% or the lowest 25% will be coming under the first quartile. Then the another 25% will be coming under second quartile, then third quartile, and the fourth quartile. So when we calculate interquartile range, we basically ignore or we basically exclude the lowest 25%. Okay, it is 25, then 50, then 75, and then 100. Okay, so we just exclude these observations. Okay, we don't take them into consideration, and we also like ignore these. So what values do we take? So we take the middle 50% values. Okay, so since we are taking the middle 50% values, so those will be somehow signifying our central tendency only. Okay, so that is the meaning of what interquartile range. So when we give it a formula, means interquartile range. So interquartile range is actually this, the range between two quartiles. Okay, so yeah, that means Q3 minus Q1, third quartile minus first quartile. So that is what interquartile range. And when we say that we are just doing half of the interquartile range, means we are doing semi interquartile range. Okay, so that is called quartile deviation. I hope you guys must be understanding these by now. Okay, and then let us move to another topic, that is deviation from mean. So you guys must be knowing now about mean. So when we have to calculate mean for a population, we just do summation of all the values that we are having, summation of x, and we divide that by number of observations. So that's how we calculate the mean. And when we talk about the deviation, so deviation is nothing but x minus x bar. Okay, deviation simply means how far the value is from a mean value. Okay, more the distance between the mean value and the observation, more will be the variation and variance. Okay, so that is quite simple, and you guys can understand this quite well. Okay, so now let us move to another thing, that is mean deviation. So this was actually deviation, and when we take mean of the deviation, so that is actually what we call mean deviation. So mean deviation, okay, is actually nothing but summation of x minus x bar, and that is divided by n. So that is called mean deviation. All right, so let us, okay, so we know how to divide that by n because it will come out to be 0 only. Okay, so one of the definition of mean is that when we calculate the mean, then the summation will always and always comes out to be 0, because some of the values will be lower than mean, some of the values will be higher than mean, and they will neutralize each other. Some will be showing positive sign, some will be showing negative sign. That's how it is going to happen. Okay, now we are moving to our one of the main topic, that is variance. So one thing that you should know by now is that variance is actually a measure of calculating the spread or the dispersion. Okay, so variance is square of the standard deviation. Here S shows standard deviation. Okay, the formula is quite clear over here, that first we have to square all the values of x, and then we have to do the summation of that, and then we have to divide that by the average of the summation x ka whole square. So here the square is of x, and here the square is of summation x, so keep that in mind. Okay, so these are two different things and not the same. Okay, and here you can see that it is n minus 1. So since we are calculating this for a sample, okay, so we are using n minus 1 and we are using s over here. However, if we had been calculating this for a sample, for a population, we would have been writing sigma square, that is equal to summation x square, and then summation x ka whole square divided by n, and it will also be divided by n. So that should be the formula then, if we will be calculating it for a population. Okay, well, there are other formula also for variance only. Okay, I'm writing that for a population, like we can do what, x minus mu. Okay, then we will do whole square, then divided by what, divided by n. Okay, so here you can see one thing, that we are just taking the square of this value. This is what deviation, this is what mean, and this is actually the mean deviation. Okay, so this is actually the deviation. Okay, and we have to do summation. So that's how we are going to calculate the variance. So there are two formulas. You can use any of them. In my personal opinion, this one seems to be quite easier, because here you need not to like calculate the mean and all. Okay, so let us see one example over here. So before doing that example, I have already told you about something called standard deviation. So standard deviation is nothing but it is actually the square root of variance. And if someone asks you like what is variance, variance is actually the square of standard deviation. So both of them are interrelated concepts. Okay, so suppose you are given with these numbers. And first thing that you have been told is find out range. Okay, we will be calculating different measures of dispersion. So first thing is the range. So range is 6 minus 3. Sorry, it is 8 minus 3. That is 5. Okay, then if we can calculate interquartile range, okay, so that is not something that we need to calculate in this. So we are just leaving it for now. So we won't be calculating interquartile range and the quartile deviation. Okay, let us move directly to our main topic. So first one was the range. Another one is variance and then standard deviation. So let us calculate those standard deviation and variance. Okay, so we first need to calculate the summation of x. Okay, and then we will calculate the summation of x square. So summation of x and summation of x square. Okay, so these are the two things that we need to do. Okay, so the formula, okay, it was written over here. So firstly, we'll have to take the summation of x square, then we have to subtract that by the average of x square with the average of the summation x. Okay, okay, so here what we have to do is that we have to take this value. Okay, so it comes out to be 25. Then we have to subtract it from the summation of x square divided by n, means 143 divided by number of observation, that comes out to be 5, and then we have to divide it by the number of observation, that is 5 minus 1, that comes out to be 4. Okay, so this is what this is something that we are calculating. It is s square, that means it is variance. Okay, so that's how we can actually calculate variance. Okay, so variance will come out to be something. Okay, so here it is given clearly. So it will come out to be 4.5, and when we will be doing square root of this 4.5, we will be getting our standard what deviation. So it will come out to be 2.12. So this is quite easy, and you can understand this quite well. So you can do multiple examples using the book or whatever source you have. Okay, so that is something that I had to tell you about. Okay, so we are done up to this, and another thing that I have to tell you, and this is the last topic for this video, that is standard error. Okay, so whenever we are doing experiments, it is very important that we have confidence on like our data. So what actually is the 95% confidence interval? So we'll be studying that in our next slide. So as of now, I'm just telling you about the standard error, because if you will be able to find out the error, then you will have some sort of confidence in your experiments. Okay, so the standard error is what? Standard error is what? Standard deviation divided by root m, and that is standard error. Okay, so you can use this formula wherever you want to. In case the value of standard deviation is given, then you can directly use that value. In case the value of variance is given, then how can you calculate standard deviation from variance? You will just need to under root that. So we can also write it in some way like under root of variance divided by under root of n, or we can write it as under root of variance divided by n. So that's how we are going to write it. Okay, I hope you guys are understanding this quite well. So in case you are facing any kind of problem, then just let me know. Thank you very much, guys. Okay.